cherry pick a particular commit from another branch and apply it to the current branch. But what if you're only interested in a single file, not a whole commit? Let me show you how to bring a given file from another branch into the current branch. So for this demo, I'm going to create another branch called feature/send email. Now in this branch, I'm going to make a change to our table of content file. So echo river to table of content.txt. Now let's make a commit and say update table of content. Now let's say we want to bring this table of content file to our master branch. So first we switch to master. Now we're going to use the restore command. You learned about this earlier in the course. So we type git restore --source, or we could use -s for short. We set this to our target branch, feature/send email. And then we specify our file name, in this case, table of content.txt. Now earlier I told you that sometimes Git cannot interpret the file name. So in those situations, we have to add double hyphens here to separate the options from the file or the files here. Now when I run this command, Git is going to restore our table of content file in our working directory from the latest version of this file stored in this branch. Take a look. So our working directory is dirty. Let's get a short status. So we have some local changes in this file. We can view the content of this file using the cat command. So cat table of content.txt. So this is the change that we applied in our feature branch. Now we can stage the change and commit it in the current branch. Let's see how we can work with branches in VS Code. As I told you in the previous section, VS Code has limited Git features. So to bring additional features, we have to install an extension called GitLens. If you missed that video in the previous section, go to the extensions panel and search for GitLens. This is the extension we're going to use to work with branches. So once you install this, you're going to see this new icon over here. Here's our Venus repository. Over here, we have this folder called branches. We can see all of our branches here. So master is our current branch, as indicated by this tick icon. We also have these folders, bug fix and feature. The reason we have these folders is because I used a / in naming these branches. So bug fix / whatever. That is the benefit of using this convention. Now here we can change the layout. So instead of a tree structure, we can view our branches in a list. So we click on this icon. Now all of our branches are listed here. In front of each branch, we can see the last time this branch was updated. So as a best practice, if you're done with a branch, make sure to delete it. Otherwise, all these branches hanging there is just going to create confusion for you. Now we can expand any of these branches to look at its history. Unfortunately, at the time of recording this lesson, we cannot see all of our branches in a graph. To do that, we're going to use another extension, which I'm going to talk about at the end of this lesson. So master is the current branch. Now I'm going to create a new branch based on the last commit on master. So we right click here, and here we have a few options. We can switch to this branch. We can rename this branch, create a new branch, and create a tag. So let's create a new branch. I'm going to call this feature/reset-password. Now we get this error saying, this is not a valid branch name. I don't know what this is coming up. Don't worry about it. Just press enter. Now here we have a few options. We can create this branch, or we can create this branch and switch to it, or we can cancel. I'm going to go with the second option. Good. So we're currently on our feature branch. We can also see the current branch over here in the status bar. Now let's make a new commit in this branch. So I'm going to open table of content.txt and say beautiful weather. Save the changes. Now we go to the source control panel. Unfortunately, VS Code is not picking up our change, so we have to refresh the view. Good. So here's the change. Let's give this commit a message. We can say, write beautiful weather to table of content. Now we make a commit. Good. So let's go to GitLens. Here in our branches, we can see this new commit over here. Now, after a while, as we make new commits, we want to compare this branch with master to see how these branches have diverged. So with our feature branch selected, here we can click on compare. And in this drop-down list, we can see all of our branches. So I'm going to select master to see how this branch is different from master. Let's expand this folder. So currently we have one commit, and this commit is in our feature branch. In a real situation, we could have several commits here, Some of these commits are on master, the others are on the feature branch. We can also see the summary of files that are changed. So in this example, our table of content file is changed. We can click on it to see the exact lines of code that have changed. In this case, we have this new line in our feature branch. So after we merge this branch into master, this new line is going to be added to table of content in master. Now I want to go back to master and make a conflicting change. So we can click on this branch on the status bar and go to master. Now let's open table of content and write something else here, like sunny day. Save the changes. Now we go to source control panel. Once again, we have to refresh the view. I don't know what's going on here. Let's say write sunny day to table of content. So we have a new commit here. Now we want to do a merge. So we get to GitLens. We're currently on master. Now we want to merge our feature branch into master. So we right click on our branch and select merge branch into current, which is master. We can also do a rebase. Either way, we're going to end up with a conflict. In this demo, I'm going to go with merge branch. Now here we have a few options. We can just do a default merge. So that is equivalent to executing git merge target branch. We have another option here, fast forward merge. So look at this option, -- only. With this, we're telling Git, hey, do a merge only if fast forward is possible. Otherwise, don't do a merge. We have another option here, no fast forward merge. We talked about this earlier in this section. If we select this, Git is going to create a merge commit even if fast forward is an option. We also have squash merge. Now in this demo, I'm going to go with the default merge. So look in the terminal window. You got a conflict in our table of content file. So on the left, we go to our source control panel. Let's refresh the view one more time. So under merge changes, we can see all conflicted files. So here we have a C, which means conflict. If we open this, we can see the conflict markers. So we can manually edit this file or use one of these options over here. In this case, I'm going to accept both changes. Save. Now, we need to commit the changes. So first, we need to stage them. So we click on this icon. Now this file is in the staging area. And here we have the default commit message. Now, let's make a commit. Good. So back in GitLens, here's our master branch. And here's our merge commit. Now let's say we screwed something up. We have a faulty merge. So we cannot compile our code or our application doesn't work. We want to undo this merge. What should we do here? Well, let's right click this. We can revert this commit. So this is going to create a new commit that will undo the changes in this commit. Unfortunately, at the time of recording this option doesn't work. So if you select this and go ahead with reverting this commit, we get this error in the terminal saying -m option was not given. We talked about this earlier in the section. So because a merge commit has two parents, we have to specify the parent number in order to revert this commit. So for this demo, I'm going to undo our merge commit. So back in GitLens, here's our merge commit. We want to reset the head to the previous commit over here. So we right click on this and select reset to commit. Here we have a few options. We can do a soft reset or a hard reset. A soft reset only updates the head pointer, but a hard reset also updates the staging area and the working directory to match the snapshot pointed to the latest commit. So here we're going to go with hard reset. Good. Now our merge commit is gone. Here in GitLens, we also have our stashes. Currently, we don't have any stashes. So I can go to our table of content file, make some changes. Now over here, we can stash all the local changes. So let's select that. Here we supply a message. Let's say new tags rows. Enter. So we have a new stash. Here we can see a summary of the changes. So we have 0 new files, 1 modified file, and 0 deleted files. Now at some point in the future, we're going to apply this stash to our working directory. So we can click on this icon, apply a stash. And here we have a few options. We can apply the stash, or we can pop this stash. This is going to apply the stash and then drop it. Or we can cancel. So I'm going to apply the stash. Okay, our changes are back. And we can still see the stash here. When we're done, we can delete it very easily. So these are some of the features we have in GitLens. Now, I told you that GitLens doesn't provide a graph of our branches. To see a graph, we should install an extension called GitGraph. So here in the extensions panel, GitGraph, it's right here. This gives us a beautiful graph of our branches. So once you install this, here in the source control panel, you're going to see a new icon called GitGraph. And now we can clearly see a graph of our branches. For example, here we have this branch, feature reset password, that is not merged into master. So we have this commit that is not included in master. Down below, you can see earlier we created this branch, and then later we merged it into master. Let's see how we can work with branches in GitKraken. So as you can see, here we have a beautiful graph of our branches. We can easily see all the branches we have created and whether these branches have been merged into master or not. For example, this feature branch, reset password, has a single commit and it hasn't been merged into master. In contrast, we have this other branch here, bugfix/change password. Earlier, we created this branch from this commit on master. We added one commit to this branch and then merged it into master. So here's our merge commit. Now let's create a new branch from master. So master is the current branch. We can also change the current branch from this drop-down list over here. Now, we right-click here and go to create branch here. Let's give it a name like feature/delete user. So now we are on this new branch. We can right-click it and rename or delete it. Now let's go to VS Code, make some changes, and add a commit to this branch. So in our table of content file, I'm going to add 2 lines, green T. Save. GitKraken has detected our changes, so let's look at them. Here's the file that we have modified. Let's stage the changes and make a commit. We can say update, table of content. Good. So our branch pointer moved forward. Now we have one extra commit here that is not in master. Next, I'm going to switch back to master and make a conflicting change. So double-click master. Here in table of content, I'm going to say black T. Okay. GitKraken has detected our change. So let's go ahead and make another commit. Good. So look, our branches have diverged. Master is here, our feature branch is over here, and we can see the divergence. Now, before doing a merge, let's compare these branches. So currently the last commit on our feature branch is selected. I'm going to hold down the shift and select the master branch. Now the tips of these branches have been selected, so we can see their diff over here. The only file that has been changed across these 2 branches is our table of content file. So take a look. Obviously, we have a conflicting change on line 3. So when we do a merge, we're going to run into a conflict. Now let's close this and do a merge. So master is the current branch. We right-click on our feature branch, and here we can do a rebase or a merge. Let's go with merge. Our merge failed. On the right side, we can see merge conflicts detected. So here we can see all the conflicted files. Let's select table of content. I love this merge tool built into GitKraken. So on the left side, we have changes on master, and on the right side, we have changes on our feature branch. Now down below, we can see the output. So we can go ahead and select the changes in master, followed by changes in our feature branch. If this is not what we want, we can always deselect one or more of these lines or change their order. Now, if you have more than one conflict, we can browse through them over here. Very simple. When we are done, we click save. Our table of content file is now staged. And here's the default commit message, merge branch, feature/delete user. Now here we can abort the merge or commit it. Let's go ahead with that. So here's our merge commit, beautiful. Now let's say we screwed something up. So we want to undo this merge. We can either revert it or reset the head to the previous commit. So with this commit selected, we can right-click and go to revert commit. GitKraken is saying, do you want to immediately commit the reverted changes? Yes. So here's the revert of our merge commit. Alternatively, we can reset the head to the commit before our merge commit. So here's our merge commit, and here's the last commit on master. We can right-click this commit and go to reset master to this commit. Here we have three options you have seen before: soft, mixed, and hard. We're going to go with hard. Good. So our merge commit is now gone. So this was the essence of working with branches in GitKraken. As you can see, GitKraken makes it incredibly easy to manage branches and resolve conflicts. So you have learned all the essential Git tools to manage your personal projects. In this section, we'll be talking about various tools that you need to master to collaborate with others. We'll start off by talking about the most common collaboration workflows. Then we're going to talk about pushing, fetching, and pulling objects from remote repositories. Next, we'll talk about the essential collaboration tools on GitHub, the most popular Git hosting platform. We'll cover pull requests, issues, and milestones. And finally, we'll talk about contributing to open source projects. The tools we're going to cover in this section are super important. You'll be using them every single day when working with a team. So let's jump in and get started. So at the beginning of the course, I told you that version control systems fall into two groups: centralized and distributed. In centralized systems like Subversion, we have a single repository that is shared by all team members. The problem with these systems is that everyone is dependent on this central repository. If the server that is hosting this repository goes offline, no one can commit or view the project history. In distributed systems like Git, every developer has a repository on their machine. So they're not dependent on a central server. They can work offline with their local repository. But how can we collaborate with this model? Well, we can synchronize our work directly with each other, but this is often too complex and error-prone. Instead, we can use what we call the centralized workflow. So everyone has their local repository, but there's also a central repository they use to synchronize their work. This is the workflow used in most private teams and closed source projects. But you might be asking, hey Mosh, what is the point of this workflow? How is it better than a centralized version control system like Subversion? Well, with this model, we don't have a single point of failure. We can work with our local repository, and if the central repository is unavailable for a period of time, we can synchronize our work directly. Now, where should we put this central repository so it's accessible to all team members? Well, some organizations put this repository on a server in their private network. Others prefer to use Git hosting services like GitHub, GitLab, Bitbucket, and so on. With all these services, we can set up our repository as a private repository, so it's only accessible to our team and no one else. So let's walk through a real scenario. John and Amy want to collaborate on a project. They start off by cloning or taking a copy of this central repository. Now they both have a local repository on their machine. So John starts working and makes a few commits. Amy could be making other commits in the meantime, but let's not worry about that yet. Now, at some point, John needs to share his work with Amy. To do that, he uses the push command to send his commits to the central repository. The central repository is now in sync with John's work. Now, Amy can use the pull command to bring in John's work into her local repository. If John's work conflicts with Amy's work, she has to resolve the conflicts and then push her changes to the central repository. So this is the centralized workflow, which is used in most private teams. Everyone in the team has push access to write to the central repository. We have another workflow for open source projects called Integration Manager Workflow. In an open source project, we have one or more maintainers and many contributors. The problem is that we don't know these contributors, so we cannot trust them enough to give them push or write access to our repository. Only the maintainers of the project have push access to the project repository. So if you want to contribute, first, we should fork the project repository to get a copy of this repository in the cloud. Next, we clone this repository to get a local copy on our machine. We make a few commits, and when we're ready to share our work, we do a push to send our commits to our forked repository. Next, we send a pull request to the maintainer of the project. This is a feature built into platforms like GitHub. I'll show you how to do that later in this section. So the maintainer of the project gets notified. Then they can pull in our changes, review them, and if they're happy, they can merge our work into their local repository and then push the merged changes to the official repository. This is called the Integration Manager Workflow because someone is in charge of integrating changes. We cannot push directly to this official repository. That's why we have to fork it to get a copy in the cloud. Because this repository is in the cloud, it's also visible to the maintainer of the project, and that's how they can pull in our changes. All right, that's it for workflows. Next, we're going to create a GitHub repository to see these workflows in action. In this section, we're going to use GitHub, which is the most popular Git hosting platform. So it's going to host our central repository in the cloud. Now, if you don't use GitHub in your organization, that's perfectly fine. You should still watch the rest of this section to learn how to collaborate with others. So head over to github.com. If you don't have an account, create one. It's free and takes only a few seconds. Just make sure to verify your email before proceeding. So here I'm logged in. Let's create a new repository on the top. All right, first we give our repository a name. I'm going to call this Mars. We can optionally give it a description. Next, we should decide if this repository is going to be public or private. If we mark this as public, anyone on the internet can see this repository. This is useful for open source projects. If we set it as private, we choose who can see and commit to this repository. But to use a private repository, we have to pay. So for this demo, I'm going to go with a public repository. Next, we can initialize this repository with a README file, with a gitignore file, and a license. I'm going to select this README file over here. So GitHub is going to add this file and create the first commit for us. Take a look. So create repository. Here's our repository. Beautiful. Now look at the URL, github.com/your username/your repository. So anyone on GitHub can have multiple repositories. Over here, you can see the current branch, that is master. We have only one branch and 0 tags. In this box, we can see the content of our project. So currently we have only a single file, that is our README file. We can click on this to see its content. Pretty basic. Now let's go back. Here on the top, we can see the latest commit. That is the initial commit that GitHub created. Here's our commit ID, the date time it was submitted, and here we can see the total number of commits. So if we click here, we can see a log of all of our recent commits. So here we can see the commits on the master branch. If we had multiple branches, we could select them here to filter the log. Now to see more details about a commit, we can click on it. So you can see this commit was submitted on the master branch. It was submitted by me about 5 minutes ago. Of course, it actually happened a minute ago, but I had to pause the recording. That is why. Here you can see a summary of the changes in this commit. So we have one changed file with 1 addition and 0 deletions. That means we have added 1 line in this file. Here's the file we're talking about, README. And over here, you can see a diff of this file. All right, now that we have a repository, next I'm going to show you how to add collaborators here. So even though this repository is public, no one but me can push or write to it. Other people can see my code and commit history, but they cannot push new commits. So if you work in a team, you should add your team members here and give them push access. Let me show you how to do this. So over here, we have a tab on the right side called Settings. Here we go to Manage Access. Now look, currently we don't have any collaborators. We can invite our team members by their GitHub username, full name, or email. So I'm going to look myself up. Here's my other GitHub account, but please, please, please don't invite me. I don't want to get 1,000 notifications every time someone watches this course and is following along. So I'm going to add myself. Now I have an invitation that is pending. So I'm going to get an email. In that email, there is a link for me to accept or decline the invitation. Once I accept the invitation, then I will have push access to this repository. So we have a GitHub repository in the cloud. Now every team member should clone this repository. That means they should take a copy of this repository and put it on their machine. Locally, they will work with that repository. When they're ready to share their changes, they will push their commits to this central repository, okay? So to clone this repository, we go to the Code tab. Here we can see the full URL of this repository. Let's copy this. We go to the terminal and type git clone and paste the URL. When we execute this command, Git is going to create a directory by the same name as our repository. If you don't like this name, you can always change it. So here we can say Mars project. Take a look. So Git cloned our entire repository. So all the commits in the central repository also exist here on my machine. Currently, we have only a single commit. Now, let's go to this directory, Mars project, and run git log So currently we have a single commit. Now look at these pointers. We have head pointing to master, and we have these two pointers in red, origin/master and origin/head. What are these? Well, when we clone a repository, Git names the source repository, in this case, the one that we have on GitHub. Git names that origin. So origin is a reference to that repository. Origin/master tells us where is the master branch in that repository. Because now we have multiple repositories, the history in each repository can evolve independently. So origin/master tells us where is the master branch in our origin repository. Now, technically, this is called a remote tracking branch. It's a branch, but it's not the kind of branch you are familiar with. So we cannot check it out. We cannot commit to it. So if you type git switch origin/master, we get an error. If we type git branch, we can see we only have a single branch, the master branch. So origin/master is a remote tracking branch. Similarly, origin/head tells us where is the head pointer in our origin repository. Now here we have a useful command you should be familiar with, git remote. This shows the list of remote repositories. A remote repository is a repository that is not on our machine. More accurately, it's not in the current directory. So currently we have only a single remote repository. That is our origin repository. If we type git remote -v for verbose, we can see more details about this remote repository. So origin is referencing this repository over here, github.com/codewithmosh/mars.git. So this is the URL that Git is going to use when we talk to this remote repository. So here's the current situation. On the left side, we have our local repository. And on the right side, we have our remote repository, which is the repository hosted by GitHub in the cloud. Now, one thing you need to understand here is that our local repository is not connected to the remote repository. So if you have a new commit in our remote repository, our local repository will not be aware of that. Here we have to use the fetch command to download this new commit. So Git is going to download this new commit and then move origin/master forward. So as I told you before, origin/master is a remote tracking branch and tells us where is the master branch in origin. In this case, it's pointing to B. Even though we downloaded this new commit, our working directory is not updated because currently master is pointing to A. That is the previous commit, the previous snapshot. So we don't have those changes in our working directory. Now, how can we bring those changes here? Well, we have two branches. Doesn't matter that one of them is a remote tracking branch. To bring those changes into master, we have to merge the other branch into master. So we switch to the master branch and type git merge origin/master. Now, in this case, our branches haven't diverged and we have a direct linear path from origin/master to master. So we're going to have a fast forward merge. In contrast, if our branches had diverged, potentially we could have a conflict. So we would have to resolve the conflict just like before. Let's see this in action. Here on GitHub, we can go to add file, create a new file, or upload files. We can also edit existing files. So in this demo, I'm going to edit our README file and create a new commit directly on this repository. So let's click on README file. Then we click on this pencil icon. Now let's add a new line of code. We can preview our changes. So we are adding this new line that is indicated by green. And over here, we can specify our commit message. So by default, GitHub is suggesting update README. We can leave it as is. Optionally, we can add some description here as well. Now here we have two options. We can commit directly to master, or we can create a new branch and start a pull request. I'll talk about the second option in the future. So let's commit this directly on master. Now, back on the homepage of our repository. So you can see we have two commits. Let's have a quick look. Here's our new commit, update README. Now, back in the terminal, we don't have this new commit in our local repository. Let me show you. So we type git log. Look, we only have this commit over here. That is the initial commit. So to download a new commit, we have to type git fetch. Then we specify the remote, in this case, origin. And optionally, we can specify a branch. So if you want to download the commits on a particular branch, we can type the branch name here. If we leave it out, we're going to download all the commits in that remote repository. Now, if we drop origin, Git assumes that we want to fetch the commits from origin. So let's go with that. All right, we fetched the new commit. let's verify it. So let's look at the log one more time. See, our remote tracking branch has moved forward. So now we have this new commit, but this commit is not on our master branch. So master is behind by one commit. There is another useful command you should be familiar with. That is git branch -vv. It shows how our local and remote tracking branches are diverging. So our master branch is linked to this branch, origin/master, and is behind by one commit. So now we have to do a merge. So we're currently on master. We type git merge origin/master. Because our branches haven't diverged and we have a direct linear path from this target branch into master, we're going to have a fast forward merge. Take a look. There you go, fast forward. Now let's look at the log one more time. So git log. So master and origin/master are pointing to the same commit. We can also verify this using git branch -vv. So we no longer have that message, one commit behind. Now we can look at the content of our README file using the cat command. So cat readme, and here's the new line that I added on GitHub. So this change is now in our working directory. So to bring the changes in a remote repository into our local repository, most of the time we have to do a fetch followed by a merge. So we have a command that combines the two. It's the pull command. Let's see how it works. So let's say our local and remote repositories are in the same state. We have a single commit in both these repositories. Now our repositories are going to evolve in different ways. So in our local repository, we're going to add this new commit, B, and in our remote repository, we're going to add this other commit, C. So when we run git pull, Git is going to download C and put it into our local repository. Note that origin/master is pointing to C. So now our branches have diverged. In this case, Git is going to perform a three-way merge to bring the remote changes into our master branch. Now, some people don't like these merge commits because they pollute the history. So alternatively, we can use rebasing here. So I'm going to undo the merge commit. We're in the same state as before. If we use the rebase option, Git is going to rebase our master branch on top of origin/master. So what is the base of our master branch? It's A. When we use the rebase option, Git is going to change the base of our master from A to C. So essentially, it's replaying our local changes on top of changes made by others. With this, we'll end up with simple, non-linear history. Now, which approach is better? Well, it depends who you ask. This has been a discussion going for years. Some people love rebasing, others prefer merge commits. Now let's see this in action. So once again, let's create another commit on GitHub. I'm going to edit README file and add yet another line of code. Now let's make a commit. Good. So back in the terminal, I'm also going to make a commit in master so our local and remote branches diverge. So we can add a new file, file1, then add it, commit it, add file1. Good. Let's have a quick look at our log. So git log. So our master branch is ahead of origin/master by one commit. But at this point, we are not aware of the commit we made on GitHub. So if we run git pull, Git is going to download the new commit in our GitHub repository and then perform a three-way merge to bring those changes into our master. Take a look. So here's the default message for our merge commit. We're going to accept it. Now back in the terminal, let's look at the log one more time. There you go. Here's our merge commit that combines the changes in origin/master and master. So we ended up with non-linear history. Now here we can use rebasing to create linear history. But before doing so, I'm going to undo this last merge commit so we end up in the previous state. So we type git reset --hard head ~1. Okay, let's look at our log. So we're in the previous state before the merge commit. Our branches have diverged. Now we can run git pull rebase to replay our local changes, in this case, adding this file on top of the changes in origin/master. So we type git pull --rebase. All right, now let's look at the log one more time. Now we have simple linear history. This commit that we have in master for adding file1 is added on top of the last commit we made on GitHub. Now look over here. My terminal window is saying that I have one commit to push to origin. I'll show you how to do that next. So in our local repository, our master branch is ahead of origin/master by one commit. So we can use the push command to send this new commit to origin. When we run this command, Git will send our new commit to the remote repository. Then it will move the master pointer forward to point to C. And finally, it will move origin/master to point to C as well. So we type git push. Next, we specified the remote repository, in this case, origin. And finally, we specified the branch we want to push, master. Now, currently we are on the master branch, so we can drop master. Also, if we drop origin, Git will assume origin by default. So we just type git push. Here we have to enter our GitHub credentials. So I'm going to add my email and password. Good. So Git sent our new commit to origin. Let's verify it real quick. So here on GitHub, look, we have 4 commits, and here's the last commit that we just pushed. Add file 1. Now, sometimes your push may get rejected. Let's see why. So once again, our local repository is ahead of origin by one commit. Now, let's say before we do a push, someone else does a push and adds a new commit to origin. Now, if we do a push, our push will get rejected because our histories have evolved differently. So Git prevents us from overwriting someone else's work. Now, I've seen some people using the force option here. This is a terrible thing you can do. With this, you're telling Git to drop other people's work and replace it with your work. This is not what we want. So unless you have a very strong reason for using the force option, you should never, ever, ever, ever use this option. Basically, you should use this only if you have screwed things up. So what can we do here? Well, we have to do a pull to bring other people's work into our local repository. Then we have to do a merge or a rebase. If there are any conflicts, we have to resolve them, and then we can do a push. Now here's a question for you. Look at the history of these 2 repositories. What commits do we have in our local repository that don't exist in origin? C and M, right? Because in both these repositories, we have A, B, and D. So when we do a push, Git will send these 2 commits to origin. Now we have the same state in both these repositories. The final code and the history of changes are identical. In the previous lesson, you saw that when I tried to push my commits, I had to enter my GitHub credentials, my GitHub username and password. Now, we don't want to enter our credentials every time we want to do a push. That is too tedious and time-consuming. The good news is that we can store our credentials in memory or on disk and tell Git where to find it. All we have to do is to set a configuration value. So we type git config -- global. We set credential.helper to. If we set it to cache, Git will store our credentials for 15 minutes in memory. If this is not sufficient for you and you want to store your credentials permanently on disk, on Mac you have to use Keychain, and on Windows you have to use Windows Credential Store. These are both storages for storing sensitive data. So our credentials will get stored in an encrypted way. So if you're on Mac, first you have to find out if Keychain Helper is installed or not. So we type git credential-osx keychain. As you can see, Keychain Helper is installed on my machine. If it's not installed on your machine, you will see the instructions to install it. It's very easy. Once you install Keychain Helper, then you set git config -- global credential.helper to osx keychain. That's all you have to do. Now, if you're a Windows user, you have to install Git Credential Manager for Windows. So head over to github.com/Microsoft/Git Credential Manager for Windows. On this page, you can find an installer. It's right here. So download this and follow the instructions. Unfortunately, I don't have a Windows machine to show the process, but it should be very easy. You shouldn't have any problems. By default, the push command doesn't transfer our tags to a remote repository. We have to explicitly push them. So let's create a new tag called version 1.0. This tag is added to the last commit. Let's verify it real quick. Okay, so here's our tag. Now this tag is only available in this repository on my machine. If I want to send this to GitHub and share it with other team members, I have to type git push origin v1.0. All right, beautiful. Our tag is now on GitHub. Let's verify it real quick. So refresh the page. Here we have one tag. Let's click here. On this page, we can see the list of all the tags in this repository. We can click a tag to see more details. So you can see who has created this tag when. And over here, you can see these assets that GitHub automatically generated for us. So we can download our entire source code at this point in time. This is very useful. Now, if we push this tag by accident, we can remove it using the push command. So we type git push origin, exactly like before, but before the tag name, we type -- delete. This is going to delete this tag from origin. Take a look. All right, our tag is gone. So back on GitHub, we no longer have a tag, but this tag is still in my repository. So if I type git log, look, this tag is still here. If we don't need it here, we can simply type git tag -d for delete v1.0. One of the GitHub features that goes hand in hand with tags is release management. We can create a release to package our software along with source code, binary files, and release notes. Let me show you. So here on the homepage of our repository, we go to tags. Then we go to the releases tab. Currently, we don't have any releases. So let's create a new release. Now over here, we can find an existing tag or create a new tag. Currently, we don't have any tags. So I'm going to type v1.0. When I create this release, GitHub will automatically add this tag to the latest commit. Next to that, we have our target branch, which is master. Here we give our release a title. We can use the same value, version 1.0. Now in this box, we can type our release notes. For example, we can type a # to add a title and say release notes. Then using hyphens, we can add bullet points. For example, we can say fixed bug 1, fixed bug 2, added the form, Now we can preview our changes. So here are our release notes. Beautiful. Now, over here, we can attach binary files. So we can include the compiled version of our application. Now, if this release is not production ready, if it's not stable, we can tick this box. This is a pre-release. And finally, we click on publish release. All right, here's our first release. We can see our release notes along with these assets that GitHub automatically generated for us. Now, if we included binary files, like the compiled version of our application, those binary files would also be listed here, okay? Now, over here, you can see this release is based on this tag, v1.0, which is added to the last commit in our repository. Here we also have a label saying this is the latest release of this repository. Now, if you made a mistake, you can always delete this release. So to the right side of this page, which is not currently in my recording window, we have two buttons, edit release and delete. Now, back to the home page of our repository. Here on the right side, you can see all the releases. So this is all about release management in GitHub. Just remember, this is not a Git feature, it's a GitHub feature. It's a high-level feature built on top of tags. So far, we've been doing all the work on master. Now let's talk about working with branches. So similar to tags, our branches are private or local by default. So if you want to collaborate with other team members using a branch, we have to explicitly push that branch the same way we push tags. So I'm going to create a new branch called feature/change password. Now this is a private branch in my local repository. It doesn't exist on GitHub. So if we run git push, we get this error saying the current branch has no upstream branch. This basically means that this branch is not linked to a branch in origin. So Git is suggesting to run this command to solve the problem. But before doing so, let's run git branch -vv. So look, here we can see our local and remote tracking branches. So master, which is a local branch, is linked to origin/master, but feature/change password is not linked to a remote tracking branch. Now to see all the remote tracking branches, we can type git branch -r. So currently we have only these two pointers, origin/head and origin/master. So to link this private branch to a branch in origin, the first time we want to push it, we have to type git push -u. That is the short form of set upstream. Then we type the remote, in this case origin, followed by the name of the branch. So feature/change password. All right, beautiful. Our branch is pushed. We can verify it on GitHub. So let's refresh this page. Now we have 2 branches, and here's our new branch. Then back to the terminal, if we type git branch -vv, you can see that this local branch is now linked with this remote tracking branch, origin/feature/change password. Also, we can look at all the remote tracking branches. So now we have a new remote tracking branch. Perfect. Now we can start working with this branch the same way we worked with master. So we can make new commits here and then push them to origin. At some point when we are done, we want to remove this branch. To do that, we type git push. Now previously we used -u. Now we're going to use -d for delete. Then we type the remote followed by the branch name, feature/change password. Now this branch is deleted from origin. We can verify it right here. So refresh. We only have a single branch. Now let's type git branch -r. Our remote tracking branch is gone. Beautiful. But what if we type git branch -vv? We still have this local branch that is linked to origin/feature/change password. But right in front of this remote tracking branch, we have gone. So even though we removed this branch from origin, our local branch is still there. So if we type git branch, we can see it's right here, and we're currently on this branch, so we cannot delete it. So we have to switch to master, and then type git branch -d feature/change password. So this is how we can create and delete branches in a remote repository. Next, I'm going to walk you through a real collaboration scenario using branches. Let me walk you through a real collaboration scenario using branches. So let's say Amy and I are going to work on a feature together. So one of us should create a feature branch and push it to GitHub. That is one way, but there is another way. We can create a branch directly on GitHub. So in this drop-down list, we can view all of our branches. We can also create a new branch. So I'm going to call this feature/change password. Enter. All right, now we have a new branch, and this branch is currently selected in this repository. Now look over here. This branch is even with master. So as we push to this branch, we can see how far this branch is ahead of master. This is very useful. Now back in the terminal, I'm going to run git fetch to get this new branch. So we got a new branch called feature/change password. We also got a new tag. That is the tag that we created earlier in this section. Now let me show you something. If we type git branch, we only see master. But what happened to our new branch? Well, let's run git branch -r. Look over here. We have a remote tracking branch. So when we ran fetch, we only got a remote tracking branch. Now we should create a private branch in our local repository that maps to this remote tracking branch. So we type git switch -c. We're going to call this feature/change password. Now we want this branch or this pointer to be at the same location as our remote tracking branch. So origin/feature/change password. All right, beautiful. Git is saying that this new branch is set up to track the remote branch from origin. Perfect. So here on my machine, I can add new commits to this branch and then push them to origin. Now I'm going to switch to another terminal window to simulate Amy's workspace. So here's Amy's workspace. Amy is going to start by cloning this repository. So we go over here, grab the URL of our repository. Good. Now we type git clone. All right, let's go to this repository. So here on Amy's workspace, if we type git branch, once again, we don't have that feature branch. So Amy should also create a private branch that maps to that remote branch. So git switch -c feature/change password. This branch should be based on origin/feature/change password. Great. Now on behalf of Amy, I'm going to make a commit and then push it to GitHub. So something really simple, we can echo password to file1, then make a commit and say update file1. Then we do a push, so git push. Beautiful. Let's verify that we have this new commit on GitHub. So here on the homepage of our repository, we can see this message, feature/change password had recent pushes 1 minute ago. Here we have a button for comparing and creating a pull request. Let's not worry about it yet. We'll talk about it soon. Instead, let's go to the list of our commits. So currently we have 4 commits. These are the commits on master. Let's change this to our feature branch. So here's the new commit that I just pushed. Beautiful. So Amy and I are going to keep pushing to this branch. And in the meantime, we have to pull each other's changes. And if there are conflicts, we have to resolve them and then do another push. Now, at some point, this feature is going to be complete. Let's say I'm the person responsible for closing this branch. So on my machine, first I have to bring in Amy's changes. So we run git pull. All right, we have a fast forward. Beautiful. Let's have a look at our history. So git log, one line all graph. Take a look. Our feature branch is one commit ahead of master. So we have to merge this branch into master. That is very easy. We switch to master and then run git merge feature / change password. Good. Once again, we have a fast forward merge because this is a very simplified example. In a real case scenario, most likely you will have conflicts. But I'm not going to repeat that here because we already talked about resolving conflicts. Now, let's look at our log again. Look, now master and feature / change password are pointing to the same commit. However, origin / master is one commit behind master. So here we have to do a push to send the final changes to GitHub. So I'm currently on master and I run git push. All right, our changes are now in GitHub. Let's look at our log one more time. So master and origin / master are now at the same location. Beautiful. Now here on GitHub, we have 5 commits. Let's have a quick look here. So here are the commits on master. Obviously, we have the commit that was for implementing the change password feature. So we're done with this feature. Now we should close this branch. So I'm going to type git push -d origin feature / change password. I'm going to remove this branch from origin as well as its remote tracking branch in my local repository. Good. Now let's look at our branches. We still have this local branch. We don't need it anymore. So let's remove it here as well. Git branch -d feature / change password. Beautiful. So on my machine, I only have the master branch. Let's look at our remote tracking branches as well. Git branch -r. Okay, we no longer have that remote tracking branch. Perfect. Now, what about Amy? Well, she's still on the feature branch. So on behalf of Amy, first we should switch to master. Now we should do a pull to bring in the merge changes that Mosh pushed. So git pull. Good. So now both Amy and I have the same history. Now let's look at our branches. We still have the private feature branch. So let's delete it real quick. Good. Now what about our remote tracking branches? So if we type git branch -r, look, we still have this remote tracking branch, even though this branch is removed from origin. To remove the tracking branches that are not on the remote, we type git remote prune origin. Now look, this remote tracking branch, origin / feature / change password is pruned. So if we run git branch -r, we no longer see that remote tracking branch. So this is how 2 or more people can collaborate on a feature. Quite often, as part of implementing a feature or fixing a bug, we would like other team members' feedback about our code. This is where we use pull requests. With a pull request, we essentially open a discussion in the team before merging a branch into master. Let me walk you through a real scenario. Let's say Amy is going to implement a new feature. So here on Amy's machine, I'm going to start a new branch, add a commit to it, and then push it to GitHub. So git switch -c feature / login. Now let's echo hello to file3.txt. Stage the file, make a commit and say write hello to file3. Now let's push this branch. So git push, the first time we should use -u to set the upstream branch. We're going to push this to origin and call it feature / login. Now I need to enter my credentials because the cache is expired. All right, beautiful. Now here on GitHub, we see this message, feature / login had recent pushes 1 minute ago. We can compare and create a pull request. Alternatively, we can go to the pull request tab and create a new pull request from here. On this page, we have to select 2 branches. The base branch, which is often master, and the target branch, which is our feature branch. So before merging this branch into master, we want to start a pull request or a discussion in the team. Now, because we're dealing with a simple change, only a single commit and no conflicts, we can see that we can automatically merge the changes. Quite often, that's not the case. We often have conflicts that we have to resolve. We'll talk about that later. Now, over here, we can see the summary of changes. So we have one commit, one file change, 0 comments, and 1 contributor. Here's the commit that we just pushed, write hello to file 3. Over here, we can see the summary of changes. So we wrote this line in file3.txt. Beautiful. Now, let's go ahead and create the pull request. In this case, because we have a single commit, GitHub used our commit message as the title for this pull request. I'm going to change this to something more descriptive. So we're implementing a new feature for social login. We want to allow the user to log in via Facebook. So social login, that's better. Here we can write some details about this pull request. So if there are things that we want other people to review specifically, we can list them here. Now let's go ahead and create this pull request. All right, here's our pull request. Beautiful. It's saying Code with Mosh wants to merge one commit into master from feature/login. Now, let's say I'm Amy. So I'm going to add Mosh as a reviewer. So over here we can see all the collaborators in this project. Earlier in this section, I told you how to add collaborators. So I'm going to add Mosh. Good. Now we have a yellow icon here saying we are awaiting requested review from Mosh Hamadani. So Mosh is going to get an email saying, Amy needs your review. Now I'm going to open another browser window on behalf of Mosh. All right, here's Mosh's screen. On this page, we're going to go to pull requests. We have one open pull request, so let's take a look. Look at this message. Code with Mosh requested your review on this pull request. So I can go ahead and add my review. Now this box pops under this button, review changes. I find this confusing, so I always like to click away to close it and get back to it later. Here we can see the summary of all the changes. So in this case, we have a single file, file 3, and we have this new line in this file. We can add comments to individual lines by clicking on this icon. I can say, this line is good, but it's better if you capitalize H. Of course, I can write a rich review using bold and italic stuff, but let's not worry about it. So let's start our review. So I added one comment to this line of code. Of course, I could add many more comments. Now I'm going to finish my review and write a general description saying, please make these changes and do another push. I can mark this as comment. I can approve this pull request, or I can request more changes. I'm going to request more changes and submit my review. Good. Now we are on the conversation tab. We can see the timeline of things that have happened. So initially, Amy started this pull request with these details. Here's the initial commit, write hello to file 3. Then Amy, or in this case, Code with Mosh, requested a review. Then Mosh Hamadani requested changes. And here are the details about these changes. So the general comment, as well as comments to individual lines of code. Also over here, we see this red icon saying Mosh Hamadani requested changes. Now back on Amy's machine, let's make a change and do another push. So I'm going to echo hello with a capital H to file3.txt. Then I'm going to stage and commit all the changes, say capitalize hello. Then let's do a push. So Amy did a push. Now back on GitHub, she can come over here and request Mosh to review the code again. So this will send Mosh a new notification, a new email. Now I come back here and see this message one more time. Code with Mosh requested your review on this pull request. So I can add my second review. Once again, I like to click away and see the updated code. So I think this is great. I'm going to take this file as reviewed and then submit my final review. So I'm going to say, everything looks perfect. Let's go ahead with merging. And then I can select approve and submit the review. All right, the changes are approved. Beautiful. Now up here on the conversation tab, next to this reviewer, now we have a tick. So we can go ahead with merging. To do that, we go down below and we have this button, merge pull request. Now here's a question. Who should merge this pull request? Well, there are two opinions. Some teams believe that the person who started a pull request should not be able to close it. The pull request should always be closed by someone else. Otherwise, these pull requests are meaningless. Anyone can start and close them. But there's also a different opinion out there. Some people argue that the person